Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest test preparation and learning platform. Guys, we have made this JEE English channel for you so that we can deliver every single JEE lecture exclusively in English. Be it you are preparing for any competitive exams like IIT JEE Mains, IIT JEE Advanced, WIT, Manipal, BITSAT, etc. You can come onto our channel and listen to our videos. We have best-in-class educators who have graduated from premium institutes in India and abroad to deliver the lecture content on this channel, guys. And don't forget to click on that subscribe button and bell notifications, more importantly, to get this timely updates. Share it, guys, share it. And guys, the topic of the day is units and dimensions. I know it's units and dimensions. I don't like this kind of, topics. No, guys, this is a very, very interesting topics. You have told you like units and dimensions not interesting. If you understand the physical significance of units and dimensions, you will come to know how interesting this topic is. Not only that, guys, it's a very easy score of basket. I mean, you can easily score in the subject with units and dimensions. Your physics scoring will become so easy. It carries at least few marks in every exam. And once you start learning this topic, you can also verify many of your calculations in your other topics. Alright, guys. So, what is this units and dimensions? See, in this physical world, when I'm trying to communicate something, I need to have something known as physical quantities. I mean, well-defined physical quantities. What I mean by physical quantities is well-defined physical quantities. For an example, I'm trying to, say this ball is very heavy. Maybe it's heavy for me, but light for you. This is not the right way of communicating things. Maybe, there is a better way of doing it so that you understand it well. You understand it well from anywhere if I'm trying to communicate things. Let's say I want to purchase something from you. I cannot say that this is a very heavy ball for me and I'm going to deliver it to you. You might not even take it. And similarly, I wouldn't be able to, define how big is this ball. Like, I don't know what is the size of this ball. So physical quantities lets me define these kind of properties of an object and as well as any kind of dynamic and kinematic properties of an object. It exactly tells me how to act in this physical world, how to communicate in this physical world. So this is like the base foundation of physics and sciences. You need to understand this point very carefully, guys. Like, this is the base foundation of many experiments in this world. And what about units? Did you understand anything? These are some, gibberish words that I just made up right now. You might not understand them because there is a communication gap and I wasn't able to communicate with you. But these units lets you have a standardized language to communicate things. So guys, what are physical quantities? Physical quantities are those that lets me help define this world, entirely this world, how the action should be taken in this world, how to define the properties of any object. And what about units? It's a language to communicate these physical quantities. And more accurately being said, units help me with a standardized way to communicate things so that you understand it well and I understand it well when we are having a talk. Alright, guys. Now, let me tell you a little bit about myself before we get into the topic. I am Murlidharan. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top-ranking US university in electrical engineering. And I'm an IITian. I filed 22+ patent applications in India, US and Canada. And guys, today I am here to teach you units and dimensions, one of the most interesting and the most useful topic in physics. It has a lot of physical significance, it has a lot of importance in real life. And you know what, today this technology progress wouldn't have been possible if we did not define physical quantities and units. For an example, if we didn't have any language, English, Hindi, Tamil or Telugu, Kannada, etc., then today we wouldn't be able to communicate things and we wouldn't have developed any philosophy, convincing people, trying to convince emotions. Humans are able to convey emotions more effectively than any other, animals in this world. So the reason being is we have this language and we have something known as this well-defined, well-established language which we have been learning and practicing for years. and then we are able to communicate philosophy. Similarly, to understand this natural phenomena of science, we always need this physical quantities. Even though they are not the experiments themselves, they are these basic definitions. They are these words like is, I, was. And this helped me really tell you like what I'm trying to do and communicate things with everyone and let go the information to everyone so that everyone understands it better. And units is the most standardized form of this language, where physical quantity is the definition, the basic definition of what should be the terminologies be, and units is the way to communicate this language. I mean, like it's the language to communicate this information. Alright guys, myself and Unacademy have something interesting for you. That's our Unacademy learning app. You can go on to Play Store and App Store and download our Unacademy learning app and attend some free special live classes with our top-notch educators in India. And not only that guys, if you're looking for some test preparation platform and if you're looking for some competitive test preparation platform, we have an Unacademy subscription for you. You can purchase our Unacademy subscription. We have live quizzes and leaderboards, like you have real-time data. And not only that guys, you also have dedicated test preparation series for you. It will be also some of the test series will be live test series, and you will have doubt clearing sessions with our top-notch educators and live sessions with our top-notch educators. Alright guys, that being said, what should you do? If you are in like 12th class, 11th class, 9th class and 10th class, you may want to go for a 24-month subscription. That suits you better because it's a 2-year long journey. And similarly, if you're in 12 months, if you're a dropout or if you have only 12 months for your preparation, and if you're on a long term, you may want to go for a 12-month subscription. And now if you're stuck in a lockdown, you only have 1 to 3 months to prepare for your rest of the competitive exams like BITSAT, WIT, etc. You may want to try the 1 to 3 months, subscription, and we have, all the content that you need to prepare for your competitive exams. And you can make use of my coupon Murli Live to get an instant discount of 10%. And guys, I know the CBSE results are out today, and most of you must have passed with flying colors. But guys, do remember that it's not just about what you do now, what you did until now. It's about what you're going to do now. Your 10th class results don't matter anymore. And it is necessary that you pass with the flying color to get into a good college. But now it's about your entrance exams. If you want to get into best of the universities and best of the institutes. And guys, start early. Don't wait for the time, because time does not wait for you. Okay guys, you understood this point? Start early. Be it preparing for exams, be it going through the concepts, be it going through JEE English or any other educational content. Start it early. That will give you the edge. That will also give you ample amount of time to understand concepts. And in the last minute, you'll only memorize things. Memorizing things would not yield any fruitful results in future as well. Alright guys, now let's get into the subject. But before that, we are going to read about something known as units and dimensions. But we need to understand the significance of units and dimensions. And we will have a look at the quote from one of the, the most renowned scientists in this world. That's Max Planck. He said that an experiment is a question which science poses to nature, and a measurement is the recording of the nature's answer. So what does this mean? He's trying to say that experiments are not possible without having standardized measurements, or any measurements in that case. So when you're trying to conduct an experiment, trying to understand the nature, trying to understand science, trying to develop a theory, you need measurements. And measurements have laid the foundation for every single theory in this world. And every scientific subject has some or the other kind of standards and measurements to do it. And especially physics is dependent a lot on measurements. I know this is the topic of physics and measurements. You are taking it as units and dimensions because this is one of the part that carries a lot of weightage in your exam. And guys, it's an easy basket of score. So do be attentive, and I'll let you know about very short tricks and tricks and tips to solve problems in this domain, and how not to solve the problems in this topics. And in fact, this is going to be very easy, and it has a lot of physical significance. It's a very, very interesting topic, guys. Stay attentive. Alright guys, so we are going to talk about physical quantities. But before that, let's understand what is a non-physical quantity. I know most of you must be knowing. You must be seeing this emoji over there, showing some sort of, emotions. And what does this mean? It's trying to communicate something, but through emotions which cannot be measured on a physical apparatus or a physical scale. So So these kind of quantities which cannot be measured with a physical apparatus or a physical scale or through any physical means are called non-physical quantities. They do not have any magnitude and they cannot be compared with anything. The best example would be emotions like happiness and how about sometimes even like being rude or anger, and these kind of emotions are non-physical quantities. Alright guys, so now this is how you communicate as a human in nature, but this is just non-physical quantities. But what about physical quantities? We are studying about physics. This means this is not part of physics. Of course, it can be or it cannot be. It's up to our understanding. But what about physical quantities? So physical quantities are the one in which we are going to deal with today, and it is the basics of the physics. So you see this weightlifter over here. Before lifting that weight, is assessing the weight first, and then is delivering certain force and momentum to lift this weight. So every action is assessing, is measuring things, and this is where the physical quantity plays a very significant role. So in this case, is assessing mass, is assessing the length at where you should be holding this bar, and is also assessing how much force and momentum you should be delivering, and etc. and etc. So these kind of quantities can be measured with scale as well, or any physical apparatus or through any physical means. But the entire gist is physical quantities helps you measure things, helps you conduct the experiments. Without them, it is not possible to conduct any experiments. And what are the different kinds of physical quantities? It can be mass, energy, momentum, work done, time, amperes, coulombs. Basically anything that has units, or even sometimes even if they do not have units. But guys, these things are something basic that you need to understand. A physical quantity is basically something that can be measured. Okay, in this case, he's assessing the weight. He's making practical assumptions using his innate intuitions. But what you are going to do, you are going to measure it on the scale. Even before he is getting started, he knows the weight of that particular bar or that barbell before he's lifting it. So you in a physical quantity, what is going, like when I'm talking about physical quantity, what is the main thing? You can assess the physical quantity with a physical apparatus or through any physical means. Sometimes you can even assess things using your arm length, foot length. That's how feet even arrive to the standards. Alright guys, so we are talking about physical quantities. So there must be some like basic physical quantities or something like that. So that must lead to help us better define rest of the physical quantities or the physical quantities themselves. So what is the way to communicate these measurements? So we understood that the way to assess the measurements or the way to understand the measurements are physical quantities. But how do you communicate these measurements? Using some 7 base fundamental quantities or fundamental physical quantities. So what is fundamental physical quantity, guys? So a fundamental physical quantity are themselves sufficient. They are self-sufficient to communicate any property or any measurement or any comparison. And they are not dependent on any other kind of physical quantity. And the next one is, you cannot derive them. You can derive them, of course, using, 2 or 3 other type of quantities, but it is not necessary that you derive them from any other kind of physical quantity. And the thing is, they define the standards and they are not dependent on any standards to define themselves. Let me repeat it, guys. So a fundamental physical quantities are self-sufficient. They can communicate, the property or measurement or comparison without being dependent on any kind of physical quantity. And they do not require any standards. They can define themselves. And there are 7 such fundamental physical quantities. So this is a small chart over here which talks about all the 7 kind of fundamental physical quantities. But the thing about this chart is everything is in some sort of units, amperes, mass, seconds. But what are the fundamental physical quantities? These are units of those fundamental physical quantities. So the first, let's not talk about the first, second, third. But mass, length, time, temperature and so on. There are 7 such base fundamental physical quantities using which you can derive pretty much any physical quantity in this world. Be it momentum, be it force, every such physical quantity can be derived using these 7 base SI unit based fundamental physical quantity. Alright guys. But how to like define and what are those 7 different types of fundamental physical quantities? So you can call it yard, inches. These are also physical quantities as well. But what are they defining? They are some sort of units. This yards, like the thing I'm highlighting right now in like the blue color. This inches, this yards. These are as well like a way to communicate this fundamental physical quantities. But are they really defining? Are they really telling me what it is? We need to first understand what the 7 types of fundamental physical quantity. See, this is where most of your like lectures that you're attending might be going wrong. So people generally start with SI units and then come down to what are the 7 types of physical quantities. But let's start the other way around. I mean, that's a good way of remembering things, but there's a better way of knowing it from the basics until the depth. Because someone might ask you in your competitive exam, what are the 7 types of physical quantity, and they'll just confuse you with an SI unit. Confuse you with the CGS unit, confuse you with an SI unit, confuse you with an MKS unit. So you must be clear on this concept that what are the 7 base types of physical quantities. And we'll start with something unique. Amount of substance. It is a type of physical quantity. Amount of substance is like the number of particles I'm talking about. It's a terminology more commonly used in chemistry. Luminous intensity. Luminous intensity is a base physical quantity. Electric current, a base physical quantity. Length, time, mass, and temperature. Guys, you must be aware of this. Length, time, mass, and temperature. So the 3 new fundamental physical quantities for you might be electric current, amount of substance, and luminous intensity. Don't worry guys, we will have a look at each kind of physical quantities as well. And now, how do I communicate this, guys? I know this is the property, I have understood, I have assessed it, now I have measured it, but how do I communicate it to you? Simply we'll make use of something known as units. So units is a standard language to communicate the measurements and compare any physical quantity. So every region in this world, like Europe, America, Africa, India, like Middle Eastern countries, every country has their own like language. Similarly, people used to communicate in different languages. Hence came into existence different standards of measurements and different unit system. Okay guys, you understood this point, right? Why there was like different unit system. People were initially using different languages and each regions had the different language. And similarly, people were also communicating using different unit system. Alright, and what is units? Units is a standard language to communicate and compare and measure any physical quantity. It is very important to understand that I cannot say this ball is heavy, but I can say that this ball weighs so and so many grams. This will rather tell you, okay, this guy is going to deliver a ball which is going to be so and so many grams, and I can read as something that I can tell about. But let's say if I'm talking about dimensions, you'll exactly understand like where should you keep it in yourself, and you'll be planning things accordingly. And this is like general example, but what about when you're talking about scientific experiments, or even exchanging things in a barter system, or buying things from Amazon or Flipkart, like JioMart, etc. So you need to understand this property that you need to understand this thing that physical quantities have led to this kind of technology development today that we have, that defining the physical quantities have led to this kind of like technology development that we have today. And units are helping you communicate every day, be it in your scientific world, be it in your daily world, etc. Even if you're purchasing from any e-commerce website, or even if you're going to any kirana store or grocery store, then still you need these physical quantities. Alright, and what are the different kinds of physical quantities, guys? What are the different kind of units, guys? And one would be like SI units. So SI means System International or System Internationale. So this is the standard international system for communicating units, the standard language. And then there is MKS system, which is nothing but, so what is MKS? So apart from SI units, MKS, CGS and FPS has abbreviation that is going to talk about the units themselves. So MKS means M stands for mass, K stands for kilograms, S stands for seconds. And similarly, in CGS units, C stands for centimeter, G stands for gram, and S stands for seconds. And in FPS units, F stands for feet, P stands for pounds, S stands for seconds. So why so many different unit systems? So many different languages. The feet, pound and seconds are being used in US still. They are a language or the units that are being used in US and Britain. They are the Britain and the American standards for measurements. And even today, guys, if you go to US and try to purchase any vegetables in the market, you'll find that you'll purchase vegetable in terms of pounds in most of the shops. Alright, guys, we have talked about the standard units for standard language for communicating the measurements, and we need we understood the significance of physical quantities to define measurements and how it has played role in our technology development or the development that we have today in this society. So let's now understand what are these 7 base physical quantities and how we are going to play around them, like when we are going to talk about problems and etc. But first, let's understand the 7 physical quantities and why they are necessary. Like why can't the other kind of base units? The base physical units be there or physical quantities be there? So the thing is, back in the days, only a few things were there that I wanted to really communicate. Or the humans back in the days, there were only few things that they wanted to communicate and they were communicating, be it in the scientific world or be it in the general world. So these 7 base physical quantities arrived from that, and they also found that once they are defining these physical quantities, they are not dependent on any other kind of base physical quantities. So let's say I want to communicate what is the brightness and how dark or how bright is this room. How would I do that? I will make use of simply a physical quantity known as luminous intensity, which is denoted by a symbol called J. J is the symbol, J is the dimension symbol. Just to, for next few minutes, just keep listening, what I'm talking about dimension symbol, you'll understand it once we get into the dimensional analysis part of it. Luminous intensity, is the way to measure the brightness or the darkness. It's basically a unit of photometry measuring the brightness of light in a room or in any environment, and it is basically used to measure, it's just like the visual intensity. It's measuring, the brightness or the intensity of the light. And J is what is called the symbol of luminous intensity. And the SI unit of luminous intensity is candela. Guys, this is new to you. Write it down if you have a pen and paper. Candela is the SI units of luminous intensity. And the earlier terms the earlier units that were being used for luminous intensity was candle power, and now there is also something known as lumen per sterdian and lux. So earlier people were using candle power because they didn't have something like this which is glowing continuously, And right now we have tube lights and LED lights, but that's a different thing. But they didn't have these kind of things back in the days. So they were making use of candle and they were assessing everything in terms of candle powers. And they were assessing things, saying that this should be this much candle power, this should be this much candle power. And now we recently arrived to another kind of units for the luminous intensity physical quantity known as lumen per sterdian. Sterdian is a solid angle. We'll talk about it, what is sterdian. And basically it's the solid angle out of any cone. If you, basically not a cone, but if you, let's say if I am, emitting some light, this light has a solid angle, which is going to look like a cone. So we are going to take this solid angle from this point as, the cone's, the stops angle. Alright, guys. And now, how do I convert this candle power if I'm given anything? See, this may not come, but a small thing to remember is candle power, candle power is equal to 0.981 candela. Which means candle power's value is more than that of candela. If you convert candela to candle power, if you are going to get that 1 candela is equal to so and so many candle power. So the candle powers, the initial value was larger than that of candela, and they are very nearby. The difference is very, very small, and 1 candle power is equal to 0.981 candela. And 1 candela is equal to 1 lumen per sterdian, 1 lumen per solid angle, or 1 lux. Alright guys, that's about luminous intensity. What you need to remember is luminous intensity as a SI unit called candela, and also a few other units that you may want to remember. What is the symbol for representing luminous intensity? J. What is luminous intensity? It's a unit of photometry used to measure the brightness or the darkness. Okay, it's basically a unit of photometry used to measure brightness or darkness. Alright, let's get into another interesting fundamental way to communicate thing, or communicate, like physical quantities or physical like information. And how to, back in the days, how would I have communicated what is the atomic constituents? How can I say, I am going to give you one atom of carbon? Does that make sense? So there was a standardized way or a physical quantity to do this that was known as amount of substance. Amount of substance is a physical quantity which is denoted by N. N is the symbol to, like a dimensional symbol to communicate amount of substance, or amount of substance is denoted by the dimensional symbol N. And guys, now we need to understand this concept very carefully. Many of the people have doubts in this. Some of the people, some of the students do ask what is mole. Some of the students do ask what is amount of substances, but most of you know this thing by mole. So mole will better tell you like what I'm talking about. But why do we need this quantity at all? Why do I need to define the amount of substance? Okay, I can say 2, 3 substance, 3, 4 substance, but in chemistry you can't really do this. When we are talking about atomic level sciences or atomic level measurements, you cannot really define things in 1, 2, 3. They don't make sense. So back in the days, people used to have carbon as a standard. And then they thought we'll make use of Avogadro number multiplied by atomic mass unit as the standard. Okay guys. So basically it's a term, amount of substance, a term often used in a chemistry, especially you're coming through this in your stoichiometry classes. And what does amount of substance tell you? Number of particles. So the amount of substance is nothing but the number of particles that makes up for that substance, or that is contained in the substance, or that is constituted in the substance. And what about it? Generally at the atomic level, and it is defined by using Avogadro number, guys. Na means Avogadro number. Okay guys, it's the amount of particles or the number of particles contained in a substance, and it is generally at the atomic level. And how do you find it out? You basically, generally use the Avogadro number to do this. Because 1, 2, 3 carbon isotopes, 12 isotopes don't make sense. So back in the days it was carbon isotopes. Now we are going to make use of amount of substance which is not dependent on carbon isotope 12, etc. And what can be these particles? Any atomic level particles, molecules, atoms, ions, electrons, etc. And the most used one should be molecules and atoms. So particles may be anything, molecules and atoms, etc., ions, etc. The most used one would be molecules and atoms. SI unit is something that you know, it's mole. So guys, did you understand this point? What is mole? What is mole? Mole is nothing but 6 into 10 to the power 23. That is the Avogadro number of particles. The value of Avogadro number is 6.022 into 10 to the power 23. Okay, many students do have this confusion. What is mole? What are we talking about mole? Okay, this comes in stoichiometry. I'll just pull it off and use it. But guys, understand the concept. What is mole? Mole is nothing but 6.022 or something 6 blah 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 into 10 to the power 23 particles. And these particles can be atoms, anything. If you multiply this mole into the mass number, atomic mass number, you will get atomic mass unit. You will get 1 gram. So guys, what is this amount of substance? Amount of substance is the physical quantity that is used to communicate the number of particles in a given substance. The number of particles, what I mean is atomic level particles. They can be molecules, they can be atoms, they can be ions, they can be electrons. But generally we are talking about molecules and atoms. And the Avogadro number is a standard used to communicate this thing. Like it's sort of that one quantity which you multiply it with atomic mass unit, you'll get many information in our general language. And mole is the SI unit. Mole is the SI unit to communicate this amount of substance physical quantity. And 1 mole is equal to 6 into 10 to the power 23 particles. These particles are atomic level particles. And what is the symbol? Symbol is N. Amount of substance as a symbol, dimensional symbol called as N. This concept must be crystal clear to you. You understood crystal, you have crystal clear clarity about amount of substance, and the last one that we spoke about, luminous intensity. Now we will get into the third kind of one. And this one is electric current, guys. What is electric current? Flow of charge. How do you measure this charge? You can't use a bag to measure this charge. You can't use, like a spoon to lift up the charges. So you don't understand it that way. You use an ammeter or some kind of, electrical instrument to measure the charges. And they are defined in this physical world using electric current, which makes more sense to us, right? Why not charges? Flow of charges is something that we don't understand very much. Not everyone understands flow of charge. Electric current makes more sense. Electric current is the fundamental unit, not the coulomb. Do keep this in your mind. They will confuse you in an exam, or they may confuse you in an exam. In some of the competitive exams, they'll just give you coulomb, electric current, mass and time. And boom. Many of the people will go there and mark, coulomb, thinking that coulomb is the basic fundamental quantity, because you understand charge is the fundamental thing. But that is true. Charge is the fundamental thing, but it is not a fundamental physical quantity. Electric current is the fundamental physical quantity. So what is electric current? Electric current is basically rate of flow of electrons or rate of flow of ions. Anything can cause electric current, and any charged particles, flow of charged particles cause electric current, and it is nothing but rate of flow of electric charges. And an electric current is said to only exist when there is a flow of charge through a region. If the charges are stationary, if the charges are just standing like that, then there is no current. The charges have to flow. The charges is what is going to, the flow of charges is what is going to make every instrument in this world to work. For example, my mobile, this laptop or the computer that you're watching from, or the mobile that you're watching from, the electrons has to flow. So electric current is about the physical world which works better, And the SI unit is amperes, guys, amperes. There's also something known as biot, and SI units for electric current is amperes. And how do we define the symbol? What is the dimensional symbol? It's I for electric current, guys. It's I. I is the symbol for electric current, or the dimensional symbol for electric current. And electric current is equal to charge by time. You need to remember this. Electric current is the fundamental quantity using which you are going to derive coulomb in terms of ampere and time. Ampere into time, basically. Alright, guys. Now we are going to get into something very easy that you know every day in your every life. Like every day in your life. Guys, the temperature. What does temperature communicate? Temperature communicates you whether something is hot or cold. It lets me know whether I should touch this object. Okay? Or whether, it's too cold to touch the object, or whether it's too hot to touch the object. And similarly, it's nothing but, like a manifestation of thermal energy. It tells you whether the heat is flowing from one source to another and which is that source. Like temperature gradient, and these stuffs will tell me how the heat is going to flow from one source to another. And basically, what is temperature? Temperature lets me communicate whether, it is hot or cold. It can be relative. So we'll have standard units to define them. And what about, what does, what other things can temperature tell you? It can talk about the thermal energy, the flow of thermal energy, or the flow of heat from one region to another. It's basically going to tell me the amount of thermal energy or the thermodynamic energy contained in the system. What is the SI units, guys? Most of you must be knowing this. Kelvins. Don't ever mark Celsius. It is kelvins. SI units of temperature is Kelvin, and there are other units that is used to denote or express temperature, that is Celsius and Fahrenheit. And now when we talk about Celsius, that is one that we keep hearing in our everyday. How do you convert Kelvin to Celsius or Celsius to Kelvin? So remember this, Kelvin as the least value. Kelvin, why do we use Kelvin as the SI unit? Because it has something known as absolute zero, which is actually too tough or impossible to achieve. And this absolute zero, this entire thermodynamic system halts. This entire internal energy halts. You just substitute, in your equations that you have learned, that the internal energy will go down completely. And we are going to make use of this K, at least as far as our syllabus is concerned. We are going to make use of the K as the dimensional symbol for temperature. To express temperature in dimensional analysis, we are going to make use of K, which is nothing but the Kelvin, which is the language used to communicate temperature, or the SI units language used to communicate the temperature. Even your weather needs temperature. So temperature is some fundamental physical quantity that you are observing every day. Guys, I told you right at the beginning, this chapter is very interesting, and this chapter has a lot of, real life significance. Just like what you are seeing right now. And how do I convert this Kelvin to Celsius, or Celsius to Kelvin? You basically should remember Kelvin is the least value, and it has something known as absolute zero, and Celsius is equal to Kelvin plus 273. And similarly, to convert Celsius or Fahrenheit into each other, or how to convert the Celsius into Fahrenheit, then you may remember this. 9 into Celsius is equal to 5 into Fahrenheit minus 32. You can take this 32 the other side, and 5 by 9, that is something, 9 by 5, that is something you can do. 9 into Celsius is equal to 5 into Fahrenheit minus 32. Guys, remember this. Fahrenheit minus 32 or Celsius plus 32. This thing tells you that hint. Fahrenheit minus 32. Okay guys. So you put in the bracket Fahrenheit minus 32 first, and then think about the equation. So it should be 9 into Celsius. You are going to multiply 9 with Celsius, because it's just a very foolish way of remembering it. But it is fine, guys. These are some tricks and easy methods to remember things. So it's Fahrenheit minus 32. Already the value of Fahrenheit has reduced, so I must be multiplying Celsius with 9. And whereas Fahrenheit minus 32 into 5. Easy, isn't it? Alright guys, let's get into something that you must be very aware of when we are talking about units and measurements. That is time. How do I communicate the instances? This much time has passed. How do I measure it? I am going to make use of clock. I can measure this. It helps me measure the time and instances. Time defines itself, because you are using it too much in your daily life. When I am trying to tell you, let's meet at so and so Vada Pav Center in Mumbai. How am I able to do that? Because I'm going to tell you also the time at 4 p.m. or 6 p.m. That is going to, better tell you when to meet. And this is also a standardization that is very much required. You need to understand the significance of time. Pretty much in every communication system, your computer, your internet system, without time, the communication is not happening. And be it back even in the time. Time has a very immense and a very enormous role in the development of the society. Until then, when people didn't understand the concept of time, people were progressing very, very slowly. I know, this is a physical quantity, but just telling you, a few stories around them. Why time is such a significant physical quantity, and what all role it plays in our life. SI units, as you know, is seconds. I'm not going to even highlight that. You guys know it really, really well. And other units that we use is hours. You can basically remember it's 60 minutes into 60 seconds. That is 3600. Really simple. And now next thing is length, guys. Buying anything, you're needing this length. Okay. There are many ways to measure length. Vernier calipers, etc. Scale. Length is just a method to communicate the size of an object. For example, even for volume, you are going to say meter cube or centimeter cube or feet cube. So length is the basic fundamental physical quantity, isn't it? I can derive this volume from length. If I know the basic length, and the SI unit to communicate length is meters. What are the other units? Centimeter, millimeter, feet. And how much is 1 meter, guys? 3.28 feet. How to remember this? Your scale. You used your scale, this little long scale, that is 1 feet. 3 such scales make 1 meter. 30 centimeters or not, I hope you remember. So it is really that simple. 1 meter is equal to 3.2 feet. And this is a fundamental method to communicate size. Next thing would be masses, guys. Masses. We are not going to make use of these balances anymore. We have all the digital scales, but it is a way to communicate the heaviness. Now I can well define this ball. I know this is this many grams or whatever, like this many pounds. Whether if like previously I lifted this kind of weight, so it's not a very tough thing. So these kinds, this you understand this point, right? It is trying to fundamentally tell me what I should be doing in this physical world, or like it in fact influences my decision. It helps me make better decisions. So this physical quantities helps me make better decisions. They help me define the things in this physical world. And not only that, guys, these units are the way to communicate it. There must be a standardized way to communicate it. If I'm going to say 1, it is not going to, the mass of this ball is 3. This is not going to say anything. But these units help me better communicate, help me more efficiently to communicate information with you and share this information with you. And the SI units is for mass is kgs, and there are grams and pounds. And how much is 1 kg? 2.2 pounds. 2.2 pounds, guys. It's very easy to remember that 2.2 pounds is equal to 1 kg. Especially if you're like a fitness freak, or if you keep watching all these fitness channels, people are talking about pounds, because even now in US, or even US now, they are using pounds. So the fundamental way to communicate heaviness is like mass, and the units being used are kgs. It's very easy, guys. I'm not going to talk again about it. You know it very well. I just wanted to give an introduction why these fundamental units are going to communicate heaviness. But you now understood why these fundamental quantities were needed. Now we will understand something more known as derived physical quantities. See, they are like physical quantities as well, right? Momentum is a physical quantity, pressure is a physical quantity, but can't you derive them from the fundamental physical quantities? So most of the quantities, or all of the quantities, can be derived from the fundamental physical quantities. Apart from the 7 fundamental physical quantity, everything is a derived physical quantity. There are 2 supplementary physical quantities as well, but for our understanding, everything apart from that 7 base fundamental physical quantity: 1 luminous intensity, 2 electric current, 3 temperature, 4 mass, 5 kgs, 6 I think it was length, and 7 amount of substance. So these, apart from the 7 fundamental physical quantities, everything else is a derived physical quantity, and you can derive this from the fundamental physical quantities. Okay, so the definition would be something like this. A derived physical quantity requires 2 or more fundamental physical quantities to derive them. A derived physical quantity requires 2 or more fundamental, that is independent physical quantities for expressing or deriving them. Now let's come to the concept of, dimensional analysis. A very interesting part, guys, and once you understand why we are making use of this, like this dimensional analysis, you'd be astonished to know that. Especially if you're new to this topic, you would love it. You would love it, and you know what? You're going to do most of your problems correct in your physics. Okay, and what are some examples of derived physical quantities? Force, Pascal, Tesla, etc. Anything mentioned over here is a derived physical quantity. Voltage, Farad, Coulombs is not a fundamental but a derived physical quantity. Pascal, anything. Newton, Tesla, Ohms. Okay, guys, I hope you got this point. And how do we express this, derived physical quantities? Using something known as the dimensions of fundamental physical quantities. M, L, T, K, I, J, N. Okay, you remember this. The dimensional symbol of mass is M. Okay, don't confuse it with MK system, meters. So understand that we are going to start with mass. Mass is something that we need all the time and every time. The fundamental, the dimensional symbol for representing mass is M, length is L, time is T, which is very easy to remember, which is very intuitive. Now, why did we come to K, Kelvin, instead of temperature? Because there is already T, so it's K as in Kelvin. There are some like symbols that are also being used, but in our subject or in our syllabus, we are going to make use of K and I for current, J for, what is J used for? Luminous intensity. And what about N? Amount of substance. Until I, you must have already seen this thing. J, I specifically had a pause so that you get this point very clearly in your mind. Mostly you're not going to get your problems around J and N. But it is good to remember that there are two other fundamental physical quantities, and maybe you can also get it, they may ask you in watts, and they will ask you to express it in terms of, J. They'll give you something watts per steradian. So now you have this area, now you have this, power, now you need to find out watts in terms of J. But this is the concept right now, right? This is the thing that you have to remember right now. J is used to denote luminous intensity, which is a fundamental physical quantity. N is used to denote the amount of substance, and the SI unit for N is mole and for J is candela. I is ampere, you remember. For K it's temperature, and it is quite obvious, it's Kelvin. Time, seconds. For length it's meters, and for mass it's kgs. Alright guys, now we'll get into the dimensional analysis. So this force, Pascal, coulombs, Tesla, Farads, etc., all these derived physical quantities can be expressed using this dimensional analysis. So I'll first go through the concepts and then we will derive it. Okay guys? So you see this M, L, M, L, M, L, T, K, I, J, N. So these are the base, and these are the order. N is the order. Okay. So basically what do I mean by base and order? Just like what you are thinking. If kgs appear twice in an expression or in a derived physical quantity, you are basically going to raise the power of mass m by 2. And similarly, let's say it's 1 by time, then you are going to raise the power of time by minus 2. Guys, get this point really clear. MLT, K are base, and they have order something known as n in this case, or it can be 0, 1, 2, 3, anything, minus 1. Okay. And what is the gist behind it? What is the point behind it? So the point behind this is, it will tell you exactly how many kgs or how many number of kgs or how many times kgs are multiplied or divided in this expression. Similarly, how many times with respect to how much, let's say how many meters with respect to time it is moving, whether it's a velocity or acceleration. So this dimensional analysis will tell me about it exactly. T to the power something, T to the power minus 2, acceleration, T to the power minus 1, velocity. Guys, get this point clearly. It's very easy to understand. So MLTK is the base, to the order n in this case, which is written is the order, which exactly tells you like how many times that the time has been divided or multiplied, how many times this temperature plays a role in this physical quantity. We'll have a look at an example. So force is generally expressed in terms of newtons, but what is force? Kg meter per second square. So what did I do? Meter, m to the power 1, kg is nothing but mass, m to the power 1, meter, length to the power 1, it is divided by second square. Mass into acceleration. So for mass we add m to the power 1, for length we add l to the power 1, and for time, that is meter per second square, is nothing but acceleration, t to the power minus 2. So I know now that my force is dependent upon acceleration. Guys, you understood this point, right? Didn't you? Similarly, let's do it for joules. So what is, work. So joules is the derived physical quantity. So we are going to, derived physical quantity, we are going to express it in terms of dimensions for work. And what is work, guys? Is it force into displacement? Yes, it is. So basically I have this force. If I remember any of the dimensional, basically I wouldn't recommend you. I want you to remember the technique M, L, T, K, I, J, N. Just remember the base quantities and remember, don't forget the formulas that you have in your mind. And you know what? As and when you keep going through this JEE syllabus, you'll come through lot of formulas, even in your CBS, you'll come through lot of formulas and you'll start memorizing things. And you know what? Then also it will become very, very easy. But initially you need to know this thing first. And then in future, you'll understand that this topic is the easiest one, it's a scoring one. What about work? Work is nothing but force into displacement. So basically, I can multiply, if I'm given force and they ask me to find work, or if I'm just given work, I know it is nothing but kg meter square per second square. So that is going to be m raised to the power 1 because kg appeared once, L raised to the power 2 because meter appeared twice, and t to the power minus 2 due to the second square in the denominator. Alright guys, so what's Pascal? Pascal is nothing but unit of pressure. How do I express it in terms of these fundamental dimensions? The dimensions. So it's force per unit area. Force divided by area. So I know that force is nothing but kg meter per second square. If I divide it by area, that is another meter square. So that would be kg by meter second square. Or kg minus meter, m to the power minus 1 and second to the power minus 1. So that is what is written over here, isn't it? M to the power 1, L to the power minus 1, T to the power minus 2 and K0. Have you noticed this? I'm intentionally putting everywhere K0. So if they give you an option, anything like, K, I, J, K, N that do not have any relationship with it, just, you have to raise that to 0. Just don't get confused with that particular thing. So you can also derive for volts. Volts is nothing but, like electric field into distance. Electric field into distance is nothing but field by coulombs and force by coulombs. And force by coulombs is nothing but force by ampere into time. Current into time. Force by current into time into this distance will give me volts. Okay. You can calculate the volts from there as well. So we will have a look at volts. It's a little bit complicated, so how to do it. So first what I'll do is I'll basically write down the formula that I remember. Okay. It's going to be first volts is equal to electric field into distance. So I know that within some distance, if there is an electric field, that is going to create a potential difference of E into D. And then I know that, I have to divide this field by coulomb charge to get the value of in terms of force. Then I know the units in terms of force. It's kg meter per second square, and the distance is in terms of meter, which is again on the numerator, and the coulomb is nothing but ampere into second. So this would become kg meter square by ampere second cube. So it's going to be m to the power 1. So meter square, that means it is going to be L to the power 2. And it is divided by S cube, which means 3 to the power minus 3, and current is expressed in I, guys. I did this problem because you need to remember I. Remember the I to the power minus 1. I is the dimensional symbol for current or units. For if you have units in amperes or biots, it's going to be I to the power minus 1. Alright guys, dimensional analysis was this easy. This easy means this easy. Like, don't you think it's a very easily scoreable, topic or subject? And you understood the physical significance, the importance of physical quantities and units. Without this, the day, we are talking about physics, these things have already arrived. Almost they have already arrived. Else you're not defining much things, So let's do another one, which is going to be finding the dimension of farad. Another complicated, like units like farad. I'm going to find the dimension of farad. My goodness me, how do I do that? You remember Q is equal to CV. So now you would apply that. You would basically take C is equal to Q by V. And then what you would do is, Again, voltage, the same old thing, force into distance or distance by Q. So that would make it force into distance by Q. Voltage would become this. And then what you would do is, you would take this Q on the top. So there should not be a Q over here, guys. Remember this thing, there should not be a Q over here. I've already taken it to the numerator. Okay. So there should not be a Q over here. So it's nothing, voltage is nothing but electric field into distance, divided by, force divided by charge is nothing but electric field into distance, that becomes force into distance by by charge, and the charge Q is equal to CV, so it's Q squared by F into D. And this is nothing but A into S, ampere into second whole square, divided by kg meter per second square, which is nothing but the units of force into meter. I'm going to take this second square to the top, to the numerator. So that's going to become ampere square second to the power 4 by kg meter square. So you see this thing, guys. Calculating Farad was little, frustrating, too many things. What is the easiest way to do it? First, jot down the formula that you remember. Q is equal to CV. Then find, C is equal to, write down Q by V. And start expressing everything in terms of fundamental units, fundamental physical quantity units like kg, meters, Kelvin, etc., amperes, joules, luminous intensity, J, etc., and etc. Okay, first write down the formula. Now for the units, or for the, for the quantity which you have to find in terms of, dimensions, or in terms of fundamental physical quantities. So you remember this point, right? This M, L, T, K, I, J, all are fundamental physical quantities. You need to express them in terms of that. So that now what you'll do is you'll write down the units in terms of beat and CGS, MKS, whatever units you remember. Write it down in terms of that, units, but in terms of fundamental physical quantities, and then put it in the MLT expression. Okay, guys, remember this point. You have to put it in the MLT expression and maintain the spacing, because beyond a point this becomes very, very confusing. Maintain the spacing. Be it for any problem, maintain the spacing. Few problems you may not need to maintain the spacing, but for dimensional analysis, if it's a complicated problem, maintain the spacing. If it's an easy problem, you should be doing it without putting your pen on the paper. So it's ampere squared by second to the power 4 by kg meter whole square. That's going to be ampere square means I squared. Second to the power 4 means T to the power 4. Length divided by length square means L to the power minus 2. And M to the power minus 1 is for the division by kgs. Remember this, guys, remember this. Write down the formula that you remember to express that units or to express that particular physical quantity in terms of dimensions. And then put in your mind that everything that we are writing in physical quantities is, in dimension analysis, is in terms of the fundamental physical quantities. Everything that we are writing in dimension analysis is in the terms of fundamental physical quantities. Once you remember these both things, then you know what to do. You need to derive everything in terms of fundamental physical quantities, be it any unit system that you remember at that moment. And now let's have a look at some standard formulas. They may ask you, what is Coulomb? How do you express this in physical units? Something like this. And what is, Weber, which is nothing but magnetic flux, which is nothing but volt into second. And they'll ask you something like, what is Tesla? How do you express this Tesla? It's Weber per meter square. So on. Henry, degree, degree Celsius, degree Celsius. How do you convert degree Celsius, guys? It's basically K to the power 1. Nothing changes. Nothing changes. You're not going to add, plus 273, or if you are given in Fahrenheit, then you're not going to do that 9 by 5 thing and everything. Do 5 by 9 thing and everything. Do remember, it's basically to the power. To the power is what you are concerned about, and I'll tell you the importance of this to the power and everything. And now we'll talk about two supplementary. Do remember this table, guys. The notes will be posted soon. I know even for the rest of the classes I haven't posted yet. I really apologize. I'll post out the notes soon, like the PDF notes will be there. And for physical quantities, please do have a look at the notes. Even for the rest of the quantities, you just have a look at the book. It should be good enough. You should be running. I would rather recommend having a look at the video rather than the, notes. But for physical quantities, do have a look at the notes. Because you have to memorize some things. A subject where you have to memorize a little bit of things, if at all necessary. All the rest is a trick. Don't study the notes now. I'll tell you a better trick even than that. So there are some supplementary physical quantities. These supplementary physical quantities are something that cannot be defined under base physical quantities or fundamental physical quantities. And the speciality of the supplementary physical quantities are they are dimensionless. They are neither derived. That means they cannot be derived from the base physical quantities, and neither they are base quantities. They cannot themselves express anything. They only express themselves. And generally or basically this supplementary physical quantities are used for expressing geometrical quantities like area of circle or volume of sphere, etc., or solid angle in a sphere, etc., like quantities like this. And the thing is, the two type of supplementary physical quantity that we have or that we are going to study are, one is plane angle and solid angles. And the SI unit of plane angle is radian. The plane angle on a plane, guys, on a plane it's radian. And on a solid, let's say this is like a bulb or something, like a light source that is projecting light. It is making a solid angle, right? It is making an angle in 3D. It's not a 2D angle, not still that, you're not going to just do that, this theta. But it's going to be this whole solid angle. Okay. So this solid angle is known as sterdian. You express solid angle in terms of sterdian. The language to communicate solid angle is sterdian. The SI unit for it is sterdian. Remember these two terms, radian, sterdian. Radian, is for plane angle, then sterdian is for solid angle. And the speciality of supplementary physical units is they do not have any dimensions. They are neither base quantities or neither they are derived quantities. They themselves cannot express anything, but they cannot be derived from any other base physical quantities. And the two types of supplementary physical quantities, guys, plane angle and solid angle. And supplementary physical quantities are basically used in geometry, mathematics to express like circle, sphere, and etc. And just for your information, this might be useful in some of your competitive exams. This might be asked. One is, how do you calculate solid angle? Area by r square. Okay. R is the radius of that sphere. Okay. This light source is going to subtend a sphere. Let's think that this is this is the light source which is going to subtend in every direction. Then this, even in any direction, then at some point in space there is a radius for this particular sphere. Okay, guys. So in this case there is this sphere, right? So let's assume I have to calculate the solid angle over here. Okay, I choose a red color, I guess that would be better. In this case, let's get a red color. Okay. So you see this cone? This cone is subtending a solid angle. This cone over here is subtending a solid angle. That solid angle is expressed in terms of sterdian. This cone itself has a solid angle, right? And what I'm concerned about, this area of this cone, this area, that the base area of the cone is what I am concerned about. This area of the cone is what I am concerned about. Okay, let's not mess it up. This area, this base area of the cone is what I'm concerned about, and I'll divide it by r square. So what is the solid angle of a sphere, guys? What is the solid angle of a sphere? What is the area of a sphere? 4 pi r square surface area. So that's going to be r square. It's going to be 4 pi. Okay, keep calculating this. This is a very simple concept. Do 3 problems, 5 problems, 10 problems. Then this solid angle will sit in your mind. And then about theta. Theta is something that you're reading every day. 2 pi r. 2 pi r is the entire thing. Then you multiply it with radius. Similar to find like a particular length of an arc, what would you do? You basically multiply the radius of that arc from the center with the angle theta. That's it. Length of the arc is equal to r into theta. To find out theta, you will divide L by r. So these are the two supplementary physical quantities, guys. Some brain teaser problem, some confuse me problem. Now it's time for some confuse me problem, guys. Challenging problem, brain teasers. Wake up, guys, wake up. So now the first question says, what is the dimension of Earth? So what's Hertz? Hertz is a unit for expressing frequency. Okay. What is the unit of Hertz? Whether it's m to the power minus 1, L to the power minus 2, t to the power 4, I square, this is not Hertz. Hertz is nothing but 1 by time. So it's going to be 1 by second. So they have given you an option to basically confuse you a little bit. So you should be choosing C. Okay. So it cannot be determined since it's not a base quantity. That does not make sense. Why? We have base quantities to express the derived quantities. So which of the following physical quantities do not have dimensions? Careful, guys, careful. Solid angle, Weber, strain, none of the above. We already studied that supplementary one do not have any dimensions. What about Weber volt into second? So it has a dimension. So this is not the correct answer. What about strain? Strain does not have dimensions, guys. It's delta L by L. So it's length by length again. Zero. Dimensions are zero. No dimension. Dimensionless. So strain is another such physical quantity which does not have any dimension. Do remember this point. Next, area of a circle is given by A is equal to pi r square. Then find the dimensions of the circle. Cannot be determined because supplementary physical quantity is involved. And m to the power 0, L to the power 2, t to the power 1. Why the bloody time did come over here? So this is the wrong option. Now, m to the power 0, L to the power 2, t to the power 0. Or m to the power 0, L to the power 3, t to the power 0. So what is the dimension of pi? Nothing. Nothing means nothing. So it's basically r square, L square. So the option should be m to the power 0, L square, t to the power 0. And guys, while we are solving this problem, you should be solving it along with me when you're, over here. And the objective is, once you started solving the problem, you'll start, noticing your mistakes. Don't ignore the mistakes. Learn from your mistakes, learn from your mistakes, and learn from your mistakes. If you don't learn from your mistakes, you are not progressing. Which of the following physical units do not have dimensions? Which of the following physical units do not have dimension? Degrees, Kelvin, strain, none of the above. If they are not said physical units or or physical quantities, then we are not worried about anything, but they are talking specifically about physical units. So strain is not the correct answer in this case, because strain is wrong, Kelvin is wrong. And what about degrees, guys? Degrees do not have dimension. We are not talking about degrees temperature over here, we are talking about degrees Sterdian, degrees like theta. Degrees angle. So degrees do not have any, it's basically about degrees, and strain do not have any, dimensions. Okay guys, my mistake. So degrees and strain do not have, which of the physical units or quantities do not have dimensions. So it's basically both strains and degrees. Both should be there. So A and C are correct answer. Do remember strain is delta L by L. So no, it's dimensionless. Degrees, we are talking about angle theta, so no dimensions. And if at all the question was specifically about physical units, they are adamant about physical units, I think the answer should be D. D should be the answer when they are talking about physical units, or if they just meant physical quantities and units interchangeable, then it is degrees and strain. Alright guys, so I would rather mark none of the above and then start arguing with the examiner. But I think answer should be degrees and strain. But let's get into the next problem. This is an interesting problem, guys. This is the JEE level problem. Come on, guys. It's very easy. I'm just challenging your intuition over here. I'm not challenging anything over here. I'm going to challenge you basic things that you have learned. If you're in 10th class, the basic things that you learned earlier. If you're in 12th class, you must have known this by now. It should be in your tips of your finger. A and B are constant. Mu is refractive index and mu is equal to a by b square. A by b to the power lambda 2. A by b lambda square. And I think in this case they are talking about mu is the refractive index, which means lambda is the wavelength. Then the dimensions of b is same as that of. Okay, they're asking you to compare the dimensions of b with that of what? Whether wavelength, pressure, volume, area. Lambda over here is wavelength. So wavelength means b cannot be same as wavelength. But let's do the problem in a easier, quick way, like within the next 20 seconds. What is mu? Refractive index. Refractive index does not have any dimensions. Refractive index is another such, like physical quantity which does not have any dimensions. So a does not have any dimension. So does the b by lambda square. What should be the unit of b? Area, isn't it? R square, lambda square, it should be area. So it should be equivalent to that of area, R square. Alright guys. Another problem, which of the following are dimensionless? Dimensionless constant. Okay, Coulomb's constant, gravitational constant, relative permittivity, permittivity and Poisson's ratio. What do you think is the answer? Permittivity as dimensions, gravitational constant as dimensions, Coulomb constant as dimensions. Constant does not mean it does not have dimensions. Relative permittivity does not have any dimensions. Okay guys, relative permittivity does not have any dimensions. So they will ask you to convert one kind of physical quantity into other kind of physical quantity. One of the ways to do that is, basically have a look at this chart. Sometimes the problem is going to be about time. So what you have to do is you have to convert the entire kg meter per second square into CGS units. So let's just do it like this: kg meter per second square. That also means 1000 grams. CGS means grams. 1000 grams into meters, 100 centimeters, that would be 10 to the power 5 times is equal to 1 Newton. Similarly, you can do that for erg and power. You have to convert it basically into, you have to convert the SI units into CGS units, centimeter, grams, seconds. Okay guys, remember this point. So why do we use dimension analysis? Dimension analysis is used to check the correctness of an equation. So in this case earlier we were trying to validate the equations, and in that case we need dimensional analysis. For an example, principle of homogeneity, which is like principle of homogeneity is used as the term to define why do we use, how do we check the correctness of the equation. It states that the dimensions on the both sides, LHS and RHS. So if you're writing down an equation, V is equal to U plus AT, A into T should have the same dimensions as V and U. So if you write any equation, if I say you V square is equal to U plus 2 AS, would you agree to the equation? No, because there was a U, which does not match the dimensions of rest of the thing. So in homogeneity, if you are adding these different terms, all of these terms should have the same dimension. So you know right away that equation is not correct. So it tells you whether the equation is correct or not at the first instance. If you run a dimensional analysis, if you get a problem in an exam and if you are confused, what is the answer? Just run the dimensional analysis. Sometimes I have seen a JEE problem where they just give you the answers in different units. And basically all you have to do is run a dimensional analysis and get the answer. So on both LHS and RHS side, or even if you add the terms, they should have, or they should follow the principle of homogeneity. That is, they should all have the same dimensions. And what else dimensional analysis lets you tell? To derive the units. So it's not value, but they should be units. To derive the units of constants. To derive the units of constants, you need dimensional analysis. Okay. So if I have gravitational constant, I do not know the units, but I know it's Gmn by r square is equal to force. I can basically equate it to Newton or kg meter per second square and find out that what dimension it has and what should be the units basically. Even though I have the constant value for pretty much everything expressed in SI units, that particular constant also has some, units. Okay guys, this should be units to derive the units of the constant and to find out the conversion factor between different units, like how we did dynes to, like newtons or newtons to dynes. But this is not the most significant one. The most significant one is you can check the correctness of your, equation or correctness of your formula in the mind. So do work around homogeneity. I told you, right? Why should we study this first? So whenever you're learning something, apply the principle of homogeneity to verify whether the equation that you remember is correct or wrong. You need to keep on doing that to verify what you're doing is correct or wrong. Guys, do remember this. Like, apply principle of homogeneity if you have any doubts about your formula or anything that you have memorized. And to derive, like if they ask you something like, derive this, units of this particular constant, like use that formula and do it. This should be units, guys. And you can find out the conversion factor like dynes to newtons, newtons to dynes. Let's come to the next one, guys. So a strategy to solve problems in dimensional analysis. So most of your problems are going to be around dimensional analysis. They may ask you what are the fundamental units in some of the exams, but they are going to specifically ask you about the dimensional analysis. Expect some problem from dimensional analysis. And maybe not in JEE Advanced, sometimes maybe not even JEE Mains, but they will confuse you around that. And let me tell you guys, this topic can be sometimes pretty time consuming. It's a very easy to work on topic. So if you see the problem, if you don't have to put a pen on the paper like mu is equal to a plus b by lambda square problem, just do it right away. It's not even like hardly 20 seconds to solve the problem. Just, you know the right answer, just move out. So try to work from your own memory. Try to, get the formulas. If it's a logical problem like what we saw before, just put down the answer if you know it, and maintain lots and lots of spacing while doing this dimensional analysis. Never spend a lot of time on any of the complicated dimensional analysis problem. Your kinematics problem can be easier than dimensional analysis problem sometimes. If you find dimensional analysis easy, well and good, great, awesome, do it. It's easy to score. But for people like me who do not remember formulas very easily, it's very easy to do work around the formulas that I remember and maintain a lot of spacing so that I don't confuse things, and also not spend a lot of time on dimensional analysis. If it looks like something, derive the value of Weber. I don't even remember what is Weber. Should I spend time? Forget that problem. One such problem exists. Stay relaxed for your exams, guys. Stay relaxed for your exams. Stay relaxed for everything that you're doing. And once began, try to complete it. If you have proceeded to half the problem, you remember the formula. You remember the formula. Okay, they ask you the dimensional analysis of it. Or if it's a logical problem, you started logical problem, attempt it. In dimensional analysis, don't give a logical problem. It's just an easy score of, easy basket of score. It's an easy basket of score. Just to go out and attempt it. If it's a logical problem, if it's like, they're asking you something like Weber or something like that. Generally, these kinds of problems are not asked in nowadays exams. But if they ask you something like that, if you remember the formula, jot down that formula, maintain a lot of spacing while deriving, the units. You have to find express in terms of SI units or, like CGS units that you remember these many days, and then go for the dimensional analysis based on, power. Base is nothing but fundamental units. Once you began it, don't get stuck. Keep watching the time. Keep getting that feel of the problem. Finish it quickly. Then move to the next problem. And one more important thing, guys. Once you complete all of the syllabus until 12th, come back to this chapter. Everything will look so easy. And look for the easiest problems in this chapter that will make your life easy, that will make everyone's life easy. Guys, look for the easiest one. And if it's a logical one, do attempt it. If it's a memory-based one, get your formulas and work around it. And carefully notice even problems that do have dimensional problems, like dimensional issues in the questions. And if you have started the problem, end it. If you remember the formula, end it. If you are stuck between something like you know until volt, then you did electric field into displacement, then you're stuck at what is force. You don't remember the Coulomb's law, then just jump out of it. It's really that simple. Okay, guys. Now let's do a thing. I think that is the end of the class for today. I've been covering other physical, like physics and measurements topic earlier as well with kinematics. If you haven't had a look at it, go and have a look at the kinematics sessions. and we have also covered projectile motion, many other topics on our channel. Do subscribe to our channel. And guys, ego kill it, love, value it, smile, keep smiling guys, keep smiling, share love, share this channel, and ego kill it, and knowledge guys, keep acquiring it and sharing it. Knowledge is one of the most valuable wealth that you can acquire. And guys, take care, stay safe. If you're looking for special live classes on Unacademy Learning app, you can go and download our Unacademy Learning app. We have top-notch educators coming now and then on our Unacademy Learning app to deliver special live classes. And guys, if you're looking for some subscription to prepare for your test or to get your doubts cleared and to attend structured live classes, we have something known as Unacademy, where you can go and get the subscription on Unacademy paid subscription. And guys, if you're in 12th, I would recommend going for 24-month subscription. And if you're a dropout, maybe like 1 year subscription, and you may want to apply this coupon Murli Live to get a 10% instant discount. Guys, stay tuned, stay safe, take care. See you in the next class.